Steps in software engineering. Requirement analysis. This phase involves gathering requirements from stakeholders to understand what the software needs to do. Design. Once the requirements are known, the system architecture and design are created. This includes defining the overall structure of the software and how its components will interact. Implementation. The actual coding of the software takes place in this phase. Developer write code based on the design specification. Testing. After implementation, the software is thoroughly tested to identify and fix any bugs or issues. This includes unit testing, integration testing, and system testing. Deployment. Once the software has been tested and approved, it is deployed to the production environment where users can access and utilize it. Maintenance. After deployment, the software may require ongoing maintenance to address bugs, add new features, or make improvements based on your user feedback. Object-oriented programming concepts. Classes and objects. Classes are blueprints for creating objects. They define the properties and behaviors that objects of the class will have. Encapsulation. Encapsulation is the bonding of data and methods that operate on data into a single unit called a class. It hides the internal state of an object and only exposes the necessary functionalities through methods. Inheritance. Inheritance allows a class to inherit properties and behaviors from another class. This promotes code's reusability and helps in creating a hierarchy of classes. Polymorph Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It enables a single interface to represent different underlying forms. Abstraction. Abstraction is the process of hiding the complex implementation details and showing only the essential feature of object. It focuses on the object does rather than how it does. Associations. Association represent the relationship between two or more classes. It can be one to many, or many to many. Objects may interact with each other through associations. Advantages of software engineering. First, structured approach. It's like following a receipt when cooking. Software engineering gives a step-by-step guide for building software, making it easier to manage and predict the outcome. Efficiency. Think of it organizing your work by following a structured process. You can save time and resources, avoiding chaos and confusion. Quality assurance. Just like checking your work before handing it in, software engineering involves through testing to ensure the software works correctly and meets standards. Maintainability. Imagine building a Lego set with clear instructions. Well engineered software is like that, easy to understand and modify without breaking it. Risk management. It's like preparing for a trip by checking the weather and planning for delays. Software engineering help anticipate problems and deal with them before before they become big issues. Customer satisfaction, like getting good service at at a restaurant. Software. Software engineering aims to make customers happy by delivering what they want when they want it and keeping it working smoothly. Advantages of object oriented programming. Modularity, think of OOP like building with Lego blocks. You can assemble different pieces together to create something bigger. And if one piece breaks, you can replace it without affecting the whole structure. Code reusability. It's like using the same recipe or different meals with OOP. You can reuse code for similar tasks, saving time and effort. Encapsulation. Imagine putting a belongings in a locked suitcase. Encapsulation protects your data and keeps it safe from unwanted changes, just like how OOP hides the inner workings of objects. Polymer polymorphism. Think of it as a using the game remote control for different devices. Polymorphism allows you to treat different objects in a similar way, making your code more flexible and adaptable. Abstraction. It's like I it's like using a map instead of studying every road in detail. Abstraction helps simplify complex system by focusing on the important part, making it easier to understand and work with. Ease of maintenance. Think of it as fixing a toy with interchangeable parts. OOP make it easier to update and maintain software without breaking other parts like replacing a broken piece of plastic.